Hey y'all, it's Miss Thomas. It is Friday. Yay, we made it through the first week of social distancing. And well, I hope y'all are social distancing, but virtual learning. And I hope y'all are doing okay. This worksheet may have been a little daunting, so I'm going to I have a feeling this video is going to be a little long. So if you just want to pause it and scroll through and look at the answers first and check to see if you did them right and only go through the ones you need to, I'm totally fine with that. Obviously, I do not know what you're doing at home, but that might be a suggestion. I went ahead and just put these answers for these first few up because I'm not going to talk through single thing, but I did want to, oh, that was crazy. I want to point out a couple of things. The first thing is all of these shapes that we're learning, the rectangle, the rhombus, and the square, they are parallelograms, right? Because by definition, the opposite sides are parallel. So anything that has a check going down this way should also go this way, if that makes sense. Okay, because all of the three to the right are parallelograms. So if it pertains to a parallelogram, it's going to pertain to all of them. Okay? So anything that has a check mark for a parallelogram should work for everything. And then if you notice, the square is the most specific, so it has like all of the properties. You'll see it has a check mark for literally every single thing. Honestly, knowing those properties is what really helps you be able to do 17 through 44, the rest of the worksheet, okay? I do not, obviously, during this time of digital learning, like I'm not expecting you to have these memorized. If we were in class, I certainly would. So you get a little bit of a break. But we're also going, a little less in depth. Maybe not so much, but I'm still giving some challenging problems. So anyways, if we look at 11 through 16, some of these are really tricky. And I drew this over here to kind of help, okay? So I mentioned this before in one of the videos, but I just wanted to remind you that this Venn diagram helps you with these kind of like statement type of questions. So let's see if I can go through some of them and see if it makes sense. So opposite sides of a square are congruent. Well, that's by definition what a square is. All sides are congruent, so then of course the opposite sides will be. All right, so it's like less specific than what it is, the actual definition is. All right, the next one, number 2, diagonals of a rectangle are perpendicular. Now, some of you may have said never, because the diagonals of a rectangle are not typically perpendicular, they're typically congruent. So why did I put sometimes? And it's because of this right here. So do you see a square is in the rectangle circle here? You get what I'm saying? So because a square is sometimes a rectangle, then we can say it's going to be sometimes, and so that sometimes would be if it's a rectangle. Let me write that down. If the rectangle is a square. Okay? All right, so then a parallelogram is a rectangle. Well, no, not always, because it could be a rhombus or a square or whatever. And it's not never, because a rectangle is within this box of a parallelogram. Okay, so sometimes a parallelogram can be a rectangle. Okay. And then number 14 is... Oops, sorry. I want to undo this right here. Sorry. I didn't want to leave those green circles to confuse you for later on. Okay, so I'm going to go back and write when the rectangle is a square. All right, so now let's go to question 14. A square is a rhombus. So you guys, does this square, does it fall within, oopsie, wrong pen. Does it fall within this circle? And the answer is yes, it always does. So even though it's just a small portion, it is always in the rhombus. Okay, now the opposite is a rhombus is a square. So if we were to go a rhombus, so we're going to color in the rhombus, is this rhombus, this whole circle, always in this square category? And so the answer is no. It's in some of it, right? So it's sometimes a square, but it's not always a square. Those can be very, very difficult. So I understand if some of y'all are like, what? That is really, really confusing. I totally get it. If you want to pause and kind of review it, try to think through it yourself. And then diagonals of a rhombus bisect opposite angles. That's just in the definition of rhombi. Okay? So that's an always. I would say these two are real tricky, and this one right here. And that one, honestly. So several of those are kind of tricky. All right, now let's actually get into kind of what I would call the meat of the review. We're putting this all together. We're actually going to be working some problems. Okay? So bear with me. Y'all can do this. I'm going to have a sip of water. And we will keep going. All right, so it says if the measure of angle 3, so this is the angle we're looking at, is 2x plus 7, and the measure of angle 4, which is this one. All right, so we have to think about the relationship of these two angles. Well, if you remember, if it's a rectangle, we know that there are going to be right angles in every corner. So how much does that mean they'll equal together? That means they will equal 90 degrees. Now, together, again, means we're going to have to do what with these two? Add them together. Is everybody okay with that? All right, so we're going to then add our like terms. They're on the same side. So 5x and then plus 5 equals 90. And then we're going to have, what are we going to do? Subtract our 5. So we're going to have 5x equals 85. And then we're going to simply divide. So we're going to do 85 divided by 5, which will give us 17. And did it just ask us to solve for x, and the answer is yes. Okay, so I'm going to kind of erase what's in the rectangle since we're going to use it over and over. All right, the next question asks us for the measure of angle A to B to C. So that is exactly what we were just working in that previous problem, so it should be 90 degrees. Okay. All right, now let's do the next one. So it says if the measure of angle 7 is 54 degrees, and you guys, I should have said this, but if I were in class, I would be having y'all use your pencil in these pictures, because it's like you're going to want to mark in the picture, but then obviously you're going to need to erase it as well, because it's like a different problem but the same picture. So I know that can kind of be a lot. On an assessment, I would only probably do like max 2 or 3 questions per picture so it doesn't get too jumbled. But I'm sorry if this did get jumbled for you. All right, so it says if the measure of angle 7 is 54 degrees, then find 6. Well, the real big special thing about rectangles are the isosceles triangles, and drawing the tick marks on the diagonals will help you. So if you go like that and that, then this one is 54 as well. Okay. All right, I'm going to erase. It says if AC is 15, so AC is the full diagonal. Wow, that was really bad. Then what is BD? Well, if we remember our properties, it says that the diagonals are congruent, so that is 15 as well. Okay. All right, the next one says if the measure of angle 11, so let me put this in, is 65 degrees, then find the measure of angle 5. Okay, so we're going to use the diagonals, the isosceles triangles. So we know 4 and 5 are the base angles that are congruent. So what we're going to do first is we're going to do 180 minus the 65, okay, which will give us 115. And then we're going to take the 115 and we're going to divide it by 2, because these two angles, 4 and 5, should be congruent. Okay, now it is a decimal. We've talked about it a lot. We tend to like panic and think we've done something wrong, but you have not. It can certainly be a decimal. So 57.5 degrees. Okay. All right. So if AB, that's a side length, and BC and DC. All right, I'm going to have to kind of draw over what I have already. So AB is 2x minus 5. BC is 12, and DC is 17. Okay, I put a distractor in this question. So basically you have to decide what are you going to put the 2x minus 5 equal to. Are you going to put it equal to the 17 or are you going to put it equal to the 12? Well, we know that a rectangle, the opposite sides are congruent. So we're going to put this actually was what we call a distractor. It is not needed. So for this problem, we're going to do 2x minus 5 equals 17. And then we're going to solve from there. Okay? Let's see if I can move this 2x minus 5. Oh man, it took everything. Okay, that was not the smartest idea then. Let's see if I can just erase it. Okay, so we're going to do 2x minus 5 equals 17 and then solve from there. So we're going to add our 5. So that's 2x equals 22, and so x equals 11. All we have to do now is, that's it. We didn't have to plug in or anything. Okay, so the next one says AE. So I'm going to write in here is 18, and then DE is 3x plus 6. So even though they're not on the same diagonal, can we still put them equal to each other? And the answer is yes, because diagonals are congruent and they bisect each other. All right, so we're gonna, I should have written that in here, over here. Okay, so 3x equals 12, so x equals 4. Okay, and now let's erase and keep going. All right, so the next one says if the measure of angle 3 is 34 degrees, so I'm going to put 34 degrees in here, then what's the measure of angle 6? Okay, so we got to do some like piecing together to get this one. This one's kind of a lot. All right, so we have to go. I guess there's really a number of ways you can do this and still get the right answer, which is really always nice about math. Okay, so I don't know about y'all, but I can see this alternate interior thing that we've talked about. Remember the Z? So if 34 is there, then 34 goes here. And then if 34 goes there, then 34 goes here. It's because of those isosceles triangles. Or maybe some of y'all saw that we have talked about this. The lady who did the first YouTube video showed us that this triangle is going to be congruent to this triangle. Like they're exactly the same. So if you reflected them over this line, you know, then angle 3 would be congruent to angle 6. And so then, therefore, you know they're going to be the same. Oops. Okay, so 34 degrees goes here. So that's just two different ways. And there's more than that. So however you kind of see it. And then it says if the measure of angle 2 is 63 degrees, then what's the measure of angle 1? Well, we know about that right angle business. Isn't 1 right there beside it? Yeah. And so we're just going to do 90 minus 63. So that's 27 degrees. Okay? All right, I'm going to have another sip of water. A lot of talking going on. All right, so rewind if you need to go over anything using the rectangle. Alrighty, and I don't know, if I were you, I would be like highlighting this, you know, and then on the next one, it's going to be rhombus. All right, so on rhombi, the very first thing I'm always going to do, I think I talked about this before, is I'm going to like put in the right angles, and I'm going to remind myself of this. Okay? All right, so it says Q to, oops, I almost messed that up already. Q to S to R is 55. So that's 8, angle 8. I could have said angle 8 there. So what is P to Q to R? Okay, let me do that in a different color. Now, there is a difference here. So the green one is like just part of it, but PQR are these two angles put together, 3 and 4. So we learned that the diagonals bisect each other. No, the diagonals bisect the opposite angles, excuse me. So this one is also 55. And then by alternate interior angles, so would these two. Okay, because this 55 is congruent to that one, and then this 55 is congruent to that one. So that means we're going to do 55 plus 55 okay, which will give us 110 degrees. All right. So then number 11, if we do this business, should be real easy, 90 degrees. All right, PT is 24, so that's here. Then PR is the whole thing, so that's 24 plus 24, or 24 times 2, which is 48 units. Okay, if the measure of angle 1 is 30 degrees, let's find Q to P to S. Q to P to S. So again, do y'all see it's that whole big angle 1 to 2. So that means this one's 30 and that one's 30, so the whole thing is 60 degrees. Okay. To me, the angles in a rhombus are much easier than the other ones because what's on one side of the diagonal is also on the other. Okay, and then number 30 is if angle 4 is 23 degrees, what is the measure of angle 5? So it will help me to do this, and then I'm going to draw this triangle again. So we had 23 degrees in here. We have 90 degrees in here. So all we have to do to find this missing angle, which is angle 5, is just add up the two that we know. So 90 plus 23, which equals 113, and then subtract that from 180. Okay? So that's, what is that? 67 degrees. Okay? So I'm checking my math in the calculator to make sure I don't make any careless mistakes. Okay, so then the biggest thing I think y'all are seeing so far is making sure we put the right angles. Okay. All right, and now let's see if we can do the last one. And then PQ is 3x minus 5, QR is 19, SR is 2y plus 4, and so it's finding x and y. Now, it seems like we should put opposite sides equal to each other, but do you see that this one has an x and this one has a y? So that's not really smart. But we do know about rhombuses or rhombi that all the sides are congruent. So this side is congruent to this one, and this one. So it doesn't matter if they're next to each other. 3x, sorry, I'd forgotten what it was, and QR is 19. So even though they're like beside each other, they're still congruent. Okay, so we're going to put 3x minus 5 equal to 19, and then we're also going to do the same thing. 2y plus 4 equals to 19. So we can equal them to the same thing because all sides are congruent. Okay. And so now let's solve those. So we're going to add 5 and minus 4. So we're going to have 3x equals 24. So x equals 8. And then we're going to have 2y equals 15. So that will be 7.5. So again, a decimal, no big deal, just it is what it is here. Did I miss anything? I don't think so. All right, so there's your rhombus. So I feel like if your head is hurting a little bit and you're like, oh my gosh, this is too much, we've kind of made it through the hard part, in my opinion. The rectangle and the rhombus are definitely the hardest ones. The square to me is the easiest. All right, let's grab a sip of water and keep on keeping on. All right. So with the square, we basically know every single measurement. We know that all of these are 90 and all of these are 90. And then that means that like 1, 2, 3, 4, 5, 6, 7, and 8 all the way around the outside are 45 because the diagonals bisect the angle. Now I'm not going to go do this around, but that's kind of what you could do all the way around. Okay, so now let's see if we can answer these questions. All right, it says, what's the measure of angle 6? We just discussed, 45. What's the measure of angle 9? We just discussed, 90. If TH is 4x minus 5 and MH is 2x plus 17. Find MA. Well, in order to find MA, we got to find x first, right? So we know that all sides of a square are congruent. So we're going to do 2x plus 17 equals 4x minus 5. Even though they're beside each other, they're all congruent. So we can solve this. So then we're going to have 2x equals 22. So x equals 11. Now pause, because I was about to put 11 in here, but that would not be correct because now we need to plug it back in. Well, which one do we plug it into? Honestly, doesn't make a difference because they're all congruent. So we could do 4 times 11 minus 5. So that's 44 minus 5 is 39. Or we could do the other one, 2 times 11 plus 17. So that's 22 plus 17, which will give me 39. So yay, we did it correct. All right. Okie dokie. I'm going to erase that so I can use the square again. All right, it says if MT, so that's the whole diagonal, then what is AF? Well, do y'all see MT is the whole diagonal, and then AF is just this little piece right here, so it's half. So we're just going to do 18 divided by 2, which is 9. Why I changed up the color, I don't know, but that's okay. Alrighty, and then the last one, MAT. So we just need to outline it so we know what we're talking about. So M to A to T, it's that whole angle, 3 plus 4, which is 90 degrees. Okay? Alright, woohoo, we've made it to the end. And it's also Friday, so you're almost there. You're so close. Alrighty, so let's see. One thing is, this is not good on my part for making this worksheet. We need to have a degree symbol in there, there, and there. We don't need it on 12 and 8 because those are just sides. Now, if y'all will follow along, I am not going to do any of this to start with, okay? I'm just simply going to fill in the picture, and then we'll kind of go from there. All right, so do we agree 12 goes here because opposite sides are congruent, and 8 would go here? All right, 40 is here. Well, it also can go here because of alternate interior angles. We can do the same thing with the 50. So the 40 is going to go here by alternate interior. The 50 is going to go here by alternate interior. And then we can find the z because these two are a linear pair, which means they equal 180. So then that's going to be 110. So if y'all notice what I just did, I found these two to be a linear pair, so I did 180 minus 70. Okay, now I'm going to use this triangle right here to find S. So if I know that the triangle, has 70 and 50, then finding this last angle is very easy. I just do 70 plus 50, so that's 120, and then subtract from 180. Okay, so that gives me 60 degrees. All right, let me put the 60 here. And then I can also put the 60 there. And then I can find, the last thing I guess I haven't found is this T. So if I can go ahead and put 110 here because do y'all agree vertical angles like that? And so then I'm going to do the same concept as I did a moment ago, but with this triangle right here. So if I know 110 and 40, if I add those together, that's 150. So if I redraw it over here, it's going to be 40, 110, and I want to find this, so I'll do 110 plus 40 is 150. And then do 180 minus 150 because it's a triangle and we know a triangle equals 180. So then that should give us 30. And then I think that gets us everything. So let's now fill it in. So x should be 12, y should be 8, z should be 110 degrees, q should be, where's q? 40 degrees. R should be 50 degrees. S is 60 degrees, T is 30 degrees, and W should be 60 degrees. Congratulations. Give yourselves a hand. Yes, I just literally clapped to myself. That was a lot. All right. So if there is anything that is unclear after going over this video, that's really your last thing to do today before the weekend, is to make sure that you understand these 44 questions pretty fully. If you don't, please shoot me a message, email, or remind. I'm going to try, fingers crossed, to get Google Classroom working this weekend. So it'll be a little easier for me to have everything compiled in one place with your responses. Going through Remind is kind of difficult each day. But we'll see. Don't hold your breath on that one. But yeah, shoot me a message if anything's not clear. We are going to continue to practice on Monday with this, and then we'll have a little quote-unquote quiz. I don't want you to stress out about that word because, it is distance learning, so I don't want you to think like, it's going to hurt your grade or anything like that. But I do want to get some feedback. So we will have a quiz next week. But I am going to send you a reminder shortly asking you to send me a few of these answers just to make sure y'all are kind of following along and doing what you need to do. Okay, so be on the lookout for that message. I hope you guys have a nice weekend. We will not be doing any work over the weekend, myself included. I'm going to enjoy my family and this pretty day. So I hope y'all will get outside as well. All right, miss you guys.